Start up right away. No delays. Advent of Code 2023, Day 18. Lavaduct Lagoon. Thanks to your efforts, the Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They asked you to take a look at the dig plan, your puzzle input. For example, seeing that I assume is up, down, left, right, and some number, and then like a hex value here. The digger starts in a 1 meter cube hole in the ground. Then they dig the specified numbers of meters up, down, left, or right, clearing 1 full meter cubes as they go. Okay. Directions are given as seen from above, so if up were north and right would be east and so on. Okay, so it's not relative. We're not like turning right or turning left or turning up. Okay, so it's just the exact direction. All right, we don't have to worry about that. Each trench is also listed with the color that the edge of the trench should be painted as an RGB hexadecimal color code. All right, that explains the color code. When viewed from above, the above example dig plan would result in the following loop of trench, having been dug out from otherwise ground level terrain. At this point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. Okay, so we're just basically doing a flood fill. All right, that seems straightforward. Now the lagoon contains a much more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. The elves are concerned the lagoon won't be large enough. If they follow their dig plan, how many cubic meters of lava could it hold? All right. I guess the color stuff is going to be for part 2. Mess around with color space. Get input 2023, day 18. So we got 640 lines. They all look like this. All right, so it's not just single digit. It could be double digit as well, I guess. I'm also going to grab this as our test input, because why not? And let's set up our template. 18. Okay, and then what day 18? We have to do this though. '23, 18. Oh, I interrupted it, didn't I? That's okay. We'll interrupt it one more time. There we go. Now day 18 is unsolved. Perfect. All right, so parsing this isn't going to be too bad. Let's create a little struct, maybe, that contains the instructions, the dig commands, maybe, call them, struct dig command, which will have a direction, I guess, direction, distance, usize, and then a color code. Should we convert the hex now or wait until part 2? I guess it couldn't hurt to convert it now, right? Usize. I type Unix. Usize. All right. And then we need a direction. enum direction is going to be up. Let's try to keep the order consistent, right? Up, right, down, left. We'll keep doing this clockwise from the top thing. All right. And now we're going to impl from stir for dig command. Okay. Oh, from stir. There you go. Import it, implement the missing numbers, and now we get a string. Our error is going to be string, sure. So it just looks like this. So we can say let words equals s split on space. Right? And that'll give us an array. It should be giving us an array of 3 words. The first word is going to be a direction. Equals word 0 parse. Unwrap. Right. And then the next one is going to be the distance. And the last is going to be a color. Let color. If I make it a color, I can parse it separately as a color, right? I don't know if I can do it like this, though. Let's try this. Color equals usize. No, I don't think it's liking it at all. Let's do it this way then. A tuple struct. And now I can parse it. Okay, so now we do impl from stir for direction, right? Except I haven't done this yet. This is going to be an OK of dig command with dir dist and color. Yeah, like that. Okay. So this becomes we just need to parse out the string match s. If it's a U, we'll do up, direction up. Actually, we can just 24 this, 3, put those here, insert direction colon colon, and then this is just returns an error. Oh, these have to be okayed. I'll fix that in a second. Error. Couldn't interpret direction format bang. S. How's that? Look good, and then we can close that. So this is up, right, down, and left. And we have to insert an OK here. Oops, let's flip those around. Put a comma there. Now it formats, okay. And then finally color. Impl from stir for color. And now I guess what we'll do is we'll strip off the left and the right on that. If let some we could do this. We could say let some color equals s dot trim. Oh, there's no trim. Oh, there there it is. Trim. Oh, it's just a little slow. Okay. Trim start and trim end versus trim left and trim right. Okay, we'll do trim end on this. Right? Else return error format bad color format s. Right? And a color should be something. Oh, trim end expected 0 argument. Okay, so trim right. Still expect 0. Well, what is it then? Okay, so but there's a different, right? There's a different trim command. I thought we could trim the left and trim the right and get the pieces. Now I'm bothered. Rust, string, trim, suffix. That was it. Suffix. I just remembered it. Suffix. Oh, it doesn't exist. Oh, maybe it's only on string. Oh, strip suffix. Strip suffix. There we go. Now we can insert that suffix, else this, right? And that should give us a new string. And then we should be able to say let some color equals string prefix of this, right? Else same error, right? So this is what it looks like. Right. Okay. All right. So now we have the color as a hex number. We can parse as different base, right? Rust parse base 16. 17. I hate this split keyboard sometimes. 2015. Wow. It's a base 16 crate. I thought parse could handle this is parse int. Can you not give it a base to parse? Parse. Just stir parse. You can't give it a base, huh? Scoop says, from stir radix. Okay, let's look at that. Come on, here we go. Go to the top. From stir radix. There we go. I guess it, well, what was I using inside color? U sizes? Yeah, U size. So, but it doesn't matter. They all should be the same, right? And then you can specify radix. Okay, so it accepts both upper and lowercase. Perfect. So then this just becomes okay. Color. Color. No. U size from stir radix color 16. There we go. And we forgot to put string here. And it doesn't like this. Arguments to this struct are incorrect. Oh, do I have to unwrap it? It's a result. Okay, so. Oh, but then that means I have to map the error because this is a parse int error. Map error. Error. Format bang. Could not parse color as a number. Color. How's that? Does that work? No, not quite. Oh, I put it in the wrong spot. There we go. All those braces and brackets and everything. But I thought the map, okay. Question mark? No, not there. That's there, that's there. Question mark here? There we go. Okay. Scoop says need a question mark. Yep. In fact, those other unwraps I did up above could probably also be question marks, right? Oh no, because these are also parse int errors. So we'll just let those fail. Okay. So I think we're at the point now where we can actually parse the input. Let lines equals AOC lib read lines. Input 2023 18.text for line in lines. And this is just going to be a vector of dig commands, right? There we go. And so this becomes self commands push line.parse.unwrap. Look at that. Oh, I guess we didn't need this error here. What else? Oh, yeah, this next warning is a good one because it's telling me I forgot to put that there. There we go. Okay. And now I got our final thing. Okay, so now, actually what I'll do is I'll start off with the test input, just so we can parse it. Let's do this. And then print them out. Let's add debug to this, and to this, and to this, and then we can dump them all out. Let's see what they look like. All right, we got index edit bounds. The len is 3, but the index is 3. 65. Oh, duh. There we go. Dir right, dist 6, color is whatever that color code is. Does that look right? Yep. Let's do that. So right 6, and then color is whatever. And then last one is U2, up 2. All right, I think we're parsing. Let's see if we can generate this dig thing now, and then I'll print that out. The reason I'm doing this with the test thing is because I think there isn't going to be any tricks between the test code and the test commands and the real commands. So if once we get this done, we just run it on the real one and take a look. All right, part 1. Where is that? All the way up there. What is this called? Trench? Hash map new. Actually, we just need a hash set. We don't need to store the data. I'm not going to store the color yet, because why? Why do that? And then we can just say for each command, we're going to run it. And then the answer is going to be trench len. So outline the trench, fill in the trench. Well, dig out the trench. And that's going to be a flood fill. But right now we need to dig out the trench, or outline the trench. So we're going to start, I guess we can just, and I've got a feeling that this is going to go all over the place. I'm just going to use isize, let row equals 0 isize. Call. So that's where we'll start. Match command. Now I'm hesitating because I want to do directional stuff. Impl direction. Get dir. Match D. And this is just going to match on all the D's and then return the direction to go. All right, so up is -1 0. Right is 0 1. Down is 1 0. And to the left we have 0 -1. Okay. So now we should be able to get the direction. Let dir, comma, dist equals match command. Well, the command is this. So all we're doing is extracting the data from it. Right? So I can just say command.dir.get dir command.dist. Right? That should be sufficient. Oh. I figured that out. Isn't dir a direction? Yeah. And then get dir has no information available. Oh, because there's a syntax error in it. How's that? How about that? Now, can I get dir? Still says unknown. What happens if I just run? Oh, hash set doesn't exist. Okay. Use associated function. Oh, it should be self. Okay, and now we just need to dig in that direction. So we're at row call right now. Oh, I don't want to forget, there was something about the first one. Yeah, it starts off with 1. Okay, so we'll just insert that there. Insert row call. Right? And now we'll just say row plus equals dir 0, call plus equals dir 1, trench insert row call. Right? And that should dig it. We don't need to dump out the commands anymore. But this says we have 12 dug, which doesn't seem right. This looks like more than 12. So we obviously have a bug somewhere. Oh, because I'm not, because I'm an idiot. For something in 0 dot dot dist. There we go. 38. That seems more reasonable. And I think that was the number. Yeah, 38. Okay. Now we just implement the flood fill. So I think we just need to scan across the top until we see our first hash and then go down into the right. Actually, you know what? Let's do this with the real input because I want to see if there's any if it's all open or if there are points where a flood fill from one point won't fill another point, right? That's the part I'm worried about. So let's do it with the full input and see what this looks like. In fact, once we've outlined the trench, let's dump it. Let mut min equals 0, 0. Let mut max equals 0, 0. Min is equal to min 0 min of row, min 1 min of call, and then we just do the same thing for max. Right? And that gives us our min max. So we can say for row, I guess we can just shadow the row up above, right? Min row to max row. And for call in min call all the way up to max call, right? If trench contains row call, print bang hash, else print bang dot println. All right, let's see what this looks like. This looks rather large is what it looks like. Wow, this is big. It wraps 3 lines plus a bunch. Okay. Here's what we're going to do is make this window a little bit smaller and see if we can make this fit. There we go. Look at this trench. Isn't this an awesome trench? All right, so what I'm seeing is it looks like there aren't any pinch points where there might be like 2 separate flood fills we need to do. Right? Okay. So what I can do is I can scan, like I was saying before, scan across the top row until I hit a hash and then go down into the right and then start a flood fill from there. All right. Digging out the trench shouldn't be too bad. Let's start with a work stack. Let mut stack equals vec bang. And we can start Oh, we don't even know where to start yet. Before we even figure this out, we have to find where to start. So we're going to say for call in min1 dot dot equals max1, let start call equals none. If trench contains contains row, which is going to be min 0, and then call, start call equals some call. Epic Blarg says the goal is to create a flood fill. Well, that's what I'm going for. I'm sure there's other ways to do it, but this is my solution. Let some start call equals start call, else panic could not find a place to start. How's that? And now it's actually start call plus 1. So we're going to create the stack. Let mut stack equals vec bang. And we're going to start off at the minimum row plus 1 and the start call plus 1, like that. And we say while let some position is equal to stack pop. How do we want to do this? First thing we'll do is insert into the trench. Pause. This should just be I size. It is. And then we can say if, well, we're doing a flood fill, I don't need to check bounds. I do need to check to see if there's a, how about we do it this way then? We'll say if trench, if not trench, insert, pause. In other words, there's already something there. Continue. Otherwise, what we'll do is we'll blindly look up, down, left, right. Because that simplifies the logic. 0, -1, pause 1, plus 1, and then we'll need a -1 here and a +1 here. I think that'll do the flood fill. Where's the code where I dump? Let's take the dump code and we can print it after and see what it looks like after the flood fill. We're still not using the field color. Well, I don't think it worked, folks. I think I broke it. Yeah. Epic Blarg has fond memories watching the C128 basic flood fill. Yeah, those are the days of the 6502 processor. That was nice. Although the 128 had a Z80 in it as well. All right, what did I do wrong? This was supposed to be pretty basic. Right? We push these things on. If we inserted, if something was already there, then we just continue and don't do any more work there. Otherwise, this wasn't supposed to be hard. This wasn't supposed to be the hard part. I mean, this is the same thing, right? If I say if trench contains pause, continue, else trench insert, pause, right? This is the same thing. No, I don't understand where it's not stopping. Let's stop after like 1,000 or something and see what it looks like. And I can just run it in basic. and bacon rather. Oh. Oh. That's why it went off the deep end. It was supposed to start in here, but I'm starting it there. Oh, because I'm an idiot. I didn't put a break statement right there. All right. We're going to replace this code now. Actually, what I can just do is back up all the way here. Back up over here, and then put a break. That was it. Once we find the start call, we stop. We need to stop looking. And then we retrieve it there. Okay. Now we got a flood fill. Okay, look at that. Isn't that beautiful? And part 1 says this number here. I can't read that because it's too small. It is 48.6 thousand. Hey, that's the right answer. Okay. Let me comment out the dumper. Where did I put that? Right here. And big large cheers. Yay. All right, we got it. And then I'm going to change color since we didn't actually use it. We are parsing it, but we're not using it. Let's just, I just wanted to rename it. I thought there was a rename option on this thing here. Wasn't there? I guess not. Well, I mean, the easiest way to do it is just put the underscore in front of it and then see what breaks. There it is. So this goes here and this goes here. There we go. Okay. Part 1 done. Git status. Git commit. -am. No. Git add source. Oh, right. I needed to git ignore data text. There we go. Git commit -am. No, just -am. There we go. 2023 day 18 part 1 done. Wizard says for part 1 I did something similar to day 10 part 2. Okay, I'll take a look at that. No current. Okay, yeah, we're done. We're done with part 1. Let's go to part 2. The elves are right to be concerned. The planned lagoon would be much too small. After a few minutes, someone realizes what happened. Somebody swapped the color and instruction parameters when producing the dig plan. Oh, they don't have the time to fix the bug. One of them asks if you can extract the correct instructions from the hexadecimal codes. Each hexadecimal code is 6 hexadecimal digits long. The first 5 hexadecimal digits encode the distance in meters as a 5-digit hexadecimal number. The last hexadecimal digit encodes the direction to dig. 0 means R, 1 means D, 2 means L, and 3 means U. So in the above example, the hexadecimal codes can be converted into the true instructions. Well, ain't that a kick in the pants? What is this? This is just the test input. And we got 952 billion cubic meters of lava. That's not going to fit in my RAM. So we can't do it this way. We can't do it the way that we just did part 1. I can write a decoder while I think about how I want to approach this, because right now I don't have a clue. How do we decode the colors? Now we actually use the color. So let's look for color. Change those back. And in part 2, Message says I got a memory allocation error when I tried the same as part 1. Yeah, unless you have 952 gigabytes of RAM, and that's only storing 1 byte per trench block. You're gonna get some memory allocation errors, I think. Yeah. Scoop says it's fine. Yeah. I honestly don't know how to approach this. I'm gonna have to do some Googling. This is one of the reasons I like Advent of Code, right? 1 is just, they're fun. 2 is you get to learn a lot of stuff. And 3 is you also get to learn new algorithms, because I bet you there's an algorithm for this. So I'm going to do some Googling on stream. First, I want to decode the instructions. So let's at least do that. So the bottom nibble is 0, 1, 2, or 3 for up, down, and left and right. Brom says yes. Good. I'm glad there's an algorithm out there. Otherwise, I'd be struggling on stream for a while. 4 command. Let's create a new set of commands. Let new command real commands. Vec new. 4 command in self commands. What we're going to do is we're going to take the color. I guess we ignore now the up, down, left, right parts of it. They said the color and direction stuff was swapped. So this must represent color, right? Red 2, ultramarine 3, lavender 2. It doesn't say what the actual colors are now, but I guess we don't care. So the command, the direction thing is going to be, so I had this really clever thing about implementing frumstr for direction. I should put these all together, right? They should all be co-located, right? So dig command goes with dig command, direction goes with direction, and then color. Oh, where did I put color? Here's color. Color goes with color. Oops. There. All right. I'm just wasting time now, right? I'm delaying things. Right. I wanted to convert the nibble to a direction. And we can just map it. Let dir equals cmd match cmd and OXF. 0 is to the right. 1 is direction down. 2 is direction left. Keep doing this with my shift key. And 3 is direction right. Right? That should be straightforward. And it's going to complain that I'm not matching other patterns, right? So let's do that. Panic. Invalid direction. In CMD. How's that? So this should give us a direction. Rom says, I finished it first with my own algorithm, in quotes, and then looked at the Reddit and saw the intended formula for it. Oh, okay. Well, you know, being able to come up with your own solution, you're one step ahead of me. All right, and then what do we do with the distance? It's just we shift it 4 bits down. Yeah, the first 5 hexadecimal digits encode the distance in meters as a 5-digit hexadecimal number. Okay. So we can just say let dist is equal to command shifted by 4 as I size. And we don't care about the color anymore. So we can say real commands push dig command of dir, dist, and color is just going to be color 0. Right, because we don't care. That was a waste to put the color in there. Well, it's useful for part 2. Command color. Still doesn't like it. Oh, I probably should. I can't read this now. Oh, dig command. Yeah, I can just do this. Right? But this is complaining about integers. Color. Brom says, but my solution was way slower. Okay. Now, why doesn't it like this? Oh, because I interestingly put the color inside a struct. But I can just .0 it, right? Well, like that? Will it let me do that? Yes. Oh, unnecessary plans around this one. Yellow duck. Thank you. Thank you for the follow. Welcome. All right, and what's less? I can't convert an I size to, oh, I did as I size. Okay. That's right. I used the coordinates for I sizes. All right, now we're done with the easy stuff. John says, so glad to see you're here today. Thank you. All right. Jan Janssen, thank you for the follow. So I'm going to write this. I'm going to type in algorithm area of a polygon. What do we got? Shoelace formula? Oh, well, I mean, that sounds like exactly what we want. How did it go from there to shoelace formula? That's pretty clever. All right. Shoelace formula is Gauss's area formula and the surveyor's formula, a mathematical algorithm to determine the area of a simple polygon whose vertices are described their Cartesian coordinates. Well, wouldn't you know, we can make Cartesian coordinates out of our input data. Okay. What is the... I have this dark thing set, so it's kind of hard to see, but there's some lines here. Any polygon edge determines the signed area of a trapezoid. All of these areas sum up to the polygon area. Okay. The signed area of a trapezoid. Does that mean this is positive here, this is positive here, and then we have a negative trapezoid and then a positive trapezoid? It's 1/2 the sum of xi yi plus 1 minus xi plus 1 yi. Well, I mean, this seems like it would be simple to implement. And that's what it's showing here, right? x1 times y2 minus y1 times x2. Is that it? I think, I mean, is that it? So we just have to figure out what the vertices are, right? And then once we have the vertices, we can just sum up the areas. I'm going to switch back. I'm going to switch back to the test input because we actually have the number that we're looking for there, 952 billion. Brom says that's the formula I found on Reddit. Okay, good. So at least we're on the right track. So this has 62 now. That was at 62? Yes. I can barely read that, but I can read it. I probably should zoom it back in because I'm not going to be dumping the thing anymore, right? I don't know what's a good size here. Boom, 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 boom. Is that good? How's that? All right. So let's see if we can calculate the vertices of the test input, and then use the use this, whatever this is. We're going to figure this out. 1/2 of the sum. Why is this like faded out here? And there's a green dotted square around this. Okay. So x1 times y2 minus y1 times x2 added to x2 times y3 minus y2 times x3 added to x3 times y1 minus y3 times x1. All right. Finneran, thank you for the follow. Welcome. Very glad to have you here. All right, let's see if we can calculate the vertices. Let's just dump out vertices, shall we? And the vertices should be easy because we don't have to loop, right? That's what we did in part 1. Where is it? Yeah, we just have to add the dist times the ders to get the vertices. So we're going to start off at vertex 0, 0. And we just need to push them into an array, right? So now that we have the real commands, for command in real commands, we can just consume it. We're not going to need it again. Let's say let mut row equals 0, right? And col equals 0. And that's going to be our first vertex. Let mut vertices equals vec bang row col. Now we'll take the real command and we'll break it apart, right? Actually, we can do this, right? Dig command dir dist ... right? Because we don't need the color. And then we can say let dir equals dir get dir. It's a little sloppy, but it works. Mizzard says you don't need to allocate a new vector. You can just calculate them on the fly and remember the previous point. That's a good point. I will have to remember to go back to 0, 0 at the end, though, because this shoelace formula apparently requires you to go back to x1, y1. Or in computer talk, x0, y0. But that should be easy enough to just throw on there, right? So let's do that. Say prev equals 0, 0. So next is going to be row plus dir 0 times dist, col plus dir 1 times dist. Does that work? Why is it giving me this weird type? Row is an I size. Oh, okay. I can just put row col in here just to be consistent, because that's what I'm going to end up doing. And dir is I size, row is an I size. So next, let's see. No, it's still giving me that weird thing. All right, well, let's just keep going. And now we have to calculate this thing here. x1 times y2. Let mut total. 900 and something billion is not going to fit in an I32. So I don't know if we want to actually start forcing it to be I64s now. But I'll use I sizes, because everything's 64 bits these days, right? People aren't going to run this on a 32-bit machine. Oh yeah, so Mizzard's saying that because we're not allocating a new vector each time, we're going to assume that all the points are consecutive, and we don't have. That's not. I mean, that's part of the way the input's designed, is that each point is consecutive to the next point. So yes, I should clarify that, I guess. So now it's total plus equals. It's going to be x1 times y2. So prev 0. No, x1. Right? X is the dot 1 coordinate times next 0. Right? This is x1 and this is y2 minus prev. This is y1 times next 2. Sorry, next 0. I was reading the 2 over here. No, that looks wrong. y1. The 1s are the prevs, right? Let's do this again, because I messed up. Open prev. x1. So the 1s is the prev. 1. Times y2. y2 is the next, and so it's next 0, which I had, minus the 1 is, so this is prev 0 times next 1. There we go. Erase Void says, why is your project Euler repo empty? Because I never really worked on it. I think I did some of it, but I never pushed it or something. Yellow Duck says, 8 a.m. for you. Are you doing this before work? I am. I don't have to start work till like 9 or so. So I'm good. All right. And then we have to add back in at the end. Oh. Well, if this is 0, 0, then it doesn't really, it's not going to add anything because we're multiplying by 0. All right, and then we just say prev equals next. So we don't actually have to add the back in the last one if we started 0, 0. total. Can't multiply I size by U size. Oh, I guess I didn't need row call, right? Because I'm not doing the making the matrix. So this is prev 0, prev 1. Well, that's not the right number. I can tell you that right now because it was supposed to be 93 billion or something. It's at least in the right order of magnitude. Yeah. So we're just off by a factor of 4. Oh, right. I was supposed to, in fact, the code, it says divide everything by 2 after you're done. So I should be even making this smaller. Which is worse, right? We're looking for this number. Oh, did I just, let's make sure I did the test input. Yeah, I've got the test input here. All right, so obviously I have a bug somewhere. Oh, Misery points out the border has a width of 1. Oh, so this doesn't include the border. That's good to know. But that's just adding up all the disks, right? So it's got to be adding the perimeter. That didn't, oh, yeah, that didn't make a difference. Did it? And if I put it back in, see, it says 117. And it's still 117. What? Wizard says it includes half the border. Yeah, okay. I still need this to be able to figure out why this is 0. Oh, it's just really small. Yeah, Mr. says the last digits change. Okay. All right, so what am I doing wrong here? Am I missing... Like I said, I didn't include going back to 0 because we're going to 0, 0. Right? And it's just, you know, it would be multiplying things by 0. Unless I did this part wrong. The previous location plus going that distance along that route. Oh, yeah, I have this backwards. Oh, no, that's right. 0, 0, and 1, 1. Right, because it's row column. All right, let's double check my multiplication here. We're starting off at 0, 0, so the first one actually isn't going to add anything, right? Maybe that's part of the problem. And I'm using the real commands instead. I mean, I guess we could dump out what the new one. Oh, we can't really dump out what the new one looks like unless we divide by 10,000 or something. All right. Get the direction, we get the distance, we add the perimeter on. And I did see, Misery, you said it includes half the border, so it should be perimeter over 2. That's not getting us where I need to be yet. The next point is going to be our previous point plus the distance we travel in the x and y coordinates. And the total is going to be, this is y1. No, I'm sorry, this is x1 times y2. Right? Minus y1 times x2. And then we put that there, so the next time through the loop, it's the next pair. And then I'm ignoring the last pair because of the 0, 0. Yeah, I don't know. I don't know what's wrong. Maybe I can print out to see if I got at least these commands correct. Let's find out. Yeah. Oh no, I got them wrong. Okay, maybe that's good because this one says right and it should be up. There's the bug right there. You guys, I'm an idiot. 952 408 144. Okay, so we have an off by one error. I'm going to cheat and not understand it and just throw a +1 because that's what computers do. All right. Off by one. Drink, says Epic. That's right. So I'm just throwing the 1 in there, not really understanding what the 1 is for. Maybe it's for the first location that we dug out. But now let's switch to the real input. And not dump out all the commands. There it is. And see what we get. A ginormous number. That's the right answer. Huzzah! Look at that. So I learned something today. This is why I do Advent to Code. I learned about the shoelace formula. And with Mizard's help telling me about the perimeter and using half the perimeter, I was able to come up with a code solution. Braun says, look at Pick's theorem.